Of course, we call them sum and difference because those identities are dealing with sum or difference of two angles. And these angles could be measured in degrees or radians, and however big or small or negative those angles are, they will all work out. Okay, so that's why they're very powerful, and also we call them identities. That means they are things that are true no matter what. But I do have a student in the second period asking me, like, why I'm using alpha and beta, why the author used those two letters. There's no reason why you have to use alpha beta. If you don't like them, you can make them like capital A and a B, right? Or even lowercase a, b, x, y, right? But sometimes, if you have to talk to some other people, from a different environment, they might get confused by your notation. But in academia, we have a convention for angles, right? So most likely in math or science, Greek letters are sometimes, reserved for angles. That's why you saw the angle theta, right? But now you have angles like alpha, beta, even gamma in the future. Just to know that there's no reason why they have to use Greek letters, but it's more conventional for you to do so. So there are two groups of identities, right? As you see over here, the first group is for the cosine function, right? Evaluated at sum or difference of two angles. Now the structure is that when you expand it, you get the product of two cosine functions adding or subtracting the product of two sine functions. Okay. And the thing that only going to mess you up is whether you're adding the two products or you're subtracting them, right? And therefore, here's my way to remember cosine of sum and difference of angles. It looks like cosine plus or minus sine. So CC plus or minus SS, right? So now you have to remember, when do you add or subtract? So keep in mind that cosines is the non-intuitive one, and it flips the sine. Therefore, you see that if you're adding two angles, you thought you're going to add up the two products, right? No, you're actually subtracting them. If it's a subtraction of two angles, then you actually add up the products of cosines and sines, right? The structure is CCSS, right? Where's the plus or minus depends on, we're adding or subtracting angles. And the sign is actually the opposite. Okay, just take a close look. Now, the next two are more intuitive. As you can see that the structure is SCCS. All right, so I'm going to go with SC plus or minus CS. To remember what's plus or minus, you're going to remember sine functions keeps the sign. That's probably not too bad to remember, right? Because to me, I don't really see any difference of pronouncing sine function and mathematical sign. For some reason, I guess that it's close enough for you to remember, hey, sine keeps the sign, right? So if the angle adding up, then you are adding up the products of CS and SC, right? If it's a minus, it's minus again, okay? But, at the end of the day, so you have to memorize all four. And tomorrow you're going to get two more. You have sum and difference of tangent. But the good news is you don't have the formula for cotangent, cosecant, and secant. It's either because that it's not necessary at all because you could have got those formulas on your own if you do need, based on the formula for cosine, sine, and tangent. And also, it's super rare to deal with, these cases, regarding the remaining three. All right. So now let's see how to use them. But just be aware of that some of the problems you might find in homework, even in our tests, seems trivial, since you have now access to calculator, right? But it's just that for some reason that they want people to be able to identify patterns, right? Train themselves for some more higher order thinking. So the way that works out might seem, meaningless, but that's, how they design those, instructions in math sometimes. Okay. As you can see here from one of the checkbook questions, if you're reading textbook, you know that it's typically the question that goes after example number 1, right? So feel free to read through example number 1 if you want, and revisit this question later. But right now, let's just work it out. But you might see it's completely pointless to justify why cosine 30 is radical derivative. Either you already know the best way to do it, right? Which is by memorizing the 30, 60, 90 triangle, right? But now they say, why don't you try something else? Like, if you realize you could make the angle 30 by subtracting 60 from 90, for some reason that you probably like 90 degree or 60 degree better than 30 degree. And you can also see how, you can apply this fancy formula of a difference of angles, right, for cosine. Let's try it, right? So we have cosine of difference of two angles, right? So let's take this chance to remember how to expand cosine of alpha minus beta. So the structure is, again, CC, right, plus or minus SS, but cosine flips the sign, right? That means looking at cosine, plus sine and sine. Angles are alpha, beta. Okay, so here we have alpha to be taken as 90, right? Beta is 60. Therefore, if you insist that you're going to write cosine 30 as cosine of 90 minus 60, okay, so you could expand it by writing cosine 90 degree times cosine 60 degree, right, plus sine 90 times sine 60. Now, back in my days, since we are not allowed to use calculator, and this is why actually you're still getting those kind of questions, even in this country, that because they want you guys to be able to figure it out, what cosine 90, cosine 60, with some other conclusions, which we could, using the unit circle definition, right? But we're gonna do it, but only once. And in the future, I'll say that if you do get questions like that in the test, I do want you to see that put down the formula, right, and show me how to break down the angles, right, to score, additional points in FRQ. But when we get to this far, I mean, by all means, use the calculator to get those, even their respective angles. Now, the standard way of doing it is to refer to the unit circle definition of sine and cosine. So you have a point in the first quadrant, and it's making an angle theta. And the point is located at x comma y. Do you guys remember that cosine theta is defined in terms of x or y or some combination of those, right? You guys remember what cosine theta is defined as? It's either y or x, right? And it turns out it's x. Okay, and once you figure that cosine theta is x, you know that sine theta must be y. Yeah, it's not too hard, you know, if you just have to remember it. So now what if I make the angle become 90 degrees? That point has to be on the y-axis, right? So what kind of a x value you're looking at for a point right there on the y-axis? 0, right? And that's why cosine 90 will be 0. That's why, you know, you kind of have to remember the rule, right? But you don't have to remember those, like those, you know, super simple facts. Well, what about sine 90? If sine is defined as the y-coordinate for a point on the y-axis on the unit circle, how much you think will be the y value of the point like that, right, on the y-axis? Unit circles are circle with radius 1 unit. It's 1, right? So sine 90 is 1. Okay. Yeah, Joanne? Because we define cosine of whatever angle for point that's along the unit circle to be its x-coordinate. If you want to make cosine 90, so the angle has to be like this, right? So the point has to be over here with a 0x. So now you could do the same thing, but it will be a bit harder to do for angles which are not 90, 180, right? So you could do that, right? But I'll say that, you know, it's not necessary. So you just figure it out, use a calculator, right? 0 for cosine 90, radical 3 over 2. No, my bad. 1/2. Right, 1/2 for cosine 60. Sine 90 is 1. Sine 60 is radical 3 over 2, right? When you know, put them together, it does work out as expected. So cosine 30 is indeed radical 3 over 2. Okay. So now again, if it's in a test, please make sure that know what you're supposed to get. You can always type it up in the calculator and know what you have to arrive at, right? And if you do have to, you know, get additional points for FRQ, you figure it out what formula you have to use. Show me. Don't pretend that I know that formula, right? Write it down. You get a point, right, for the formula, and show me the substitution, right? And then with some algebra, you know, you can cheat a little bit by just using the calculator somewhere along the way, right? Because at that point, I'm going to assume that you know the right way to do it, and I don't feel like, you know, getting crazy about things like that. But again, you know, it feels like that, you know, we're just making things, you know, unnecessarily complicated for no reason, right? I admit that. I wish I have an answer because, you know, yeah, just because we can. But it's yeah, I don't have a good answer. You know, I normally will try very hard to justify why we're doing this in math, right? But yeah, so this is that bad, you know. I don't. Yeah, it does remind me when I was in. Seriously, it does remind me like when I was learning it. Since we don't have calculator, this is something that we have to do. But now it's like, you know, why would you take train if you could have taken a plane? Right? Not necessarily. I mean it. You know, I think that 10 years ago, my wife has to visit, you know, her relative in California. For some reason, you know, she decided to take the train from California all the way back to Florida. And took her a week. Yeah. So You won't believe this, because she never had the kind of experience with, like a train in America, because, it's very different in a different country, and I guess that, well, also that's our first year here, and she had some like a cup noodle cup, whatever, right? But they don't have hot water on the train. Maybe she didn't figure out there might be some hot water, and she said she put room temperature water in a cup and put it over the sun to heat up. They said, how long did? No, the thing is that's not gonna work at all. You can wait for a day, it's not gonna warm up, right? So basically, she's just waiting for hours until the noodle gets softer because it's soaked in the water, right? Well, you asked for the train experience, I didn't ask. I don't know how she figured it out. Anyway, so see that, you kind of make some sense, of everything in your life, right? That's one of those. But anyway, so now let's take a look at the second one, which might be a little bit better, because now you're pretty much going from the right side of the identity going back, because now sometimes you might want to do that to challenge your memorization, right? Or like a pattern recognition. So somehow they say, can you find out the exact value of this combination of sine, cosine, 40, 70, by noticing it's C plus, right, S. So that, the pattern you're expecting from the right-hand side of cosine of the difference of two angles, right? Therefore, you realize this is nothing but cosine 70 minus 40, right? And you can expand it just to see if you do get the right pattern, right? It's CC, right? Cosine, right? And cosine flip the sign. That's why it's a minus to start with, but later it becomes a plus. So now it's cosine 30, right? Which is a bit better than 40 or 70. And we already worked out cosine 30 is radical 3 over 2. And that's it. It worked out even easier, right? But I guess that it's more meaningful since now you actually be more alerted, right, to this pattern. Okay. All right. Now, no. Now, number 3 is, a very good problem. Could be, a good, FRQ for a test. So we're going to verify the identity. And now you're not only limited to those fundamental identities like I gave you on those cheat sheets, right, back in last week. You have at least 4 more, which are the cosine and sine of sum and difference. You're going to get 2 more for tangent, and a few more, later on in this chapter. So again, to verify identities, we always have to pick a side, right? And you're going to pick the more complicated side to start with. In this case, it's the left-hand side. You see that there's not much you have to do, or just, there's nothing you can do about the denominator, right? At least the right-hand side, you notice, oh, it's the difference of 2 angles, right? So again, it will be cosine, you have the minus, but then you're going to turn into a plus, right? Sine alpha, sine beta, right, over cosine alpha. Oops, that's a multiplication. So at this point, so I hope you guys recall one of the tips from last week. I think it's tip number 4, number 3. They say that if you see a single term fraction with multiple terms on the numerator, split up the numerator, right? See what happens. You're gonna write it as 2 fractions, right? The first one with numerator cosine alpha, cosine beta, right? Divided by or over cosine alpha, cosine beta, right? Plus then the second term in the numerator, oops, over the same denominator. Now those two guys are identical, right? You divide them, you get 1. So then the second term, I hope that you realize those interesting combination of a sine of an angle divided by the cosine of the same angle. So that turns into tangent, right, of that corresponding angle. And you have another pair, right? So it'll be tangent beta. Okay, and that's indeed the right-hand side. So that's why I think that's, kind of nice to see, now with additional tools in the inventory, right? You have the fancier version of those identities involving sine and cosine, right? If you find yourself no choice but to do that, then you start with, I'll say that pretty intuitive, setup, right? And later, hopefully that you still remember some of the tips, right? Back in 6.1, and I don't think that you're gonna miss the remaining part, okay? Yeah, I'll say that 4 points at most, right, for a question like that, but still, to me, not enough for a FRQ. But I'm not making a third test anyway, so if you do have a question like that, it should be a good one. Yes, Juan. Sure. Let me. We have the mock test Thursday. Friday. Yeah, we should be able to do it. Well, at least 1 day. But if we can ever get more days than that, that we're definitely gonna do that, right? Because guys, don't forget that the test is about not just 6.1 to 6.3, it's 6.1 to 6.5, but we're skipping 6.4. The quiz is about 6.1 to 6.3. That means I have to seriously review for you guys, the 6.5, which is solving for trig equations. Okay, so that's definitely going to be a day. Then if we see it necessary after most people taking a quiz, then we'll go over some of the things, reviewing maybe the 6.1 to 6.3 material, right? So at least 1 day, hopefully more than that. Anyway, so let's move on to checkpoint 4. Now again, the kind of questions that you probably don't see any point of doing it, because what's the point, to figure out what sine of 5 pi over 12 is, even though it's in radians, right? You could have just typed it in a calculator. They say let's use the fact that you can break up the 5 pi over 12 into pi over 6 and pi over 4, which are special angles, right? And pretending you have no access to calculator, so you can still figure it out using the special triangles, right, and some basic right angle trigs. But since they're literally telling you, hey, think about the angle as the sum of 2 angles. You try to find out the sum, the sine of it, right? So you better look at sine of sum of 2 angles, alpha and beta. And now quickly think about how should you write down the general form. Sine, right? That means it's going to be sine, cosine, right? CS, right? Plus SC. Oh no, the other way around. Sorry, it's SC, right? Plus CS. So cosine, sine, right? Alpha, beta, alpha, beta. So here we're taking alpha to be pi over 6, beta is pi over 4. So we rewrite sine of 5 pi over 12 as sine of pi over 6 plus pi over 4. Okay. You break it up into sine pi over 6, cosine pi over 4, plus cosine pi over 6 times sine pi over 4. All right, so now, I mean, you seriously want to just use the calculator to figure these out, right? So this is, yeah, go ahead, Max. Oh, yes, yes, yeah, thank you. Yeah, it's a typo. Good catch. All right. Okay, so sine pi over 6, which is sine 30, right? It's 1/2. Sine pi over 4, cosine pi over 4, radical 2 over 2, right? Cosine pi over 6 is radical 3 over 2. Sine pi over 4 is radical 2 over 2. Okay. So please understand that even though that you're expected to know how to figure these out in the right way with the right triangles and stuff, right? But I mean, if I will be okay for you to skip some of the work, right? Because you've showed me most of the work, right? So how was I supposed to know that you didn't do the standard way to get those things, right? So, but again, think about that since you have access to calculator. So now work them out. It will be radical 2 over 4 plus radical 6 over 4, right? If you want, you can combine them as radical 2 plus radical 6 over 4. So make sure you know that radicals don't add up. It's not radical 8 on the top. All right, so you're gonna have to keep it as is. So that's why, I mean, if you see a problem, you know, whatever they wanted to do, if you can type it in, right, sine 5 pi over 12, get it in a calculator. Know what you're supposed to get. Then, you know, if it's FRQ, you just have to make sure that you're hitting 3 or 4 major steps, right, to score, you know, that many points. But you definitely want to know what you're supposed to get to make sure that at least you're on the right track. Let me zoom out a little bit more. Okay. Turns out that we've done 4 checkpoints, and they will be very good reference for you to try some of the quiz, questions in the packet, right? So before I forget, I better share with you so that you guys hopefully will get started trying those quiz questions. So just take a look at these questions, like from, you don't have to do it. I'm just saying that if you were looking at question 9, 10, 11, and 14. So you can definitely refer to the checkpoints 1 to 4, the ones that we just did, to figure them out. Okay. Like I said, try them, all right, so that you're not, because you're gonna get busy, in a week or two. So I'll say that figure them out, get your work in the notebook, right, so you can easily review them whenever you feel like coming to actually get the quiz done, right? But you need to have, get those work done as early as you can. Okay. But as you can see that there's some questions that require checkpoint 5, right? So let's take a look at checkpoint 5. So here they are asking us to figure out all these, functions involving sine, cosine, alpha plus beta, or some other combinations. And they decide to tell you that sine alpha is 4/5, but angle alpha is a second quadrant angle. You guys know what second quadrant angle is? An angle greater than 90, right? That means it will potentially cause you some sign errors if you don't realize. Now, what the good news of sine beta is that it's a first quadrant angle, right? So less than 90, acute angle, right? So whatever you know, right angle tricks will work out just fine. All right, so now let's think about letter A. Cosine alpha. Well, we know sine alpha, which is 4/5. Now, didn't we do that before? Like if you're given a trig function of a certain angle, right? And they were asking you to figure out the remaining 5 trig functions of the same angle, right? And the way it works is to just draw the right triangle, right? Label the angle alpha, label the sides, right? Given sine, 4/5. So opposite is 4, right? Hypotenuse 5, and the adjacent side will be square root 5 square minus 4 square, right? Which is 3, right? But in general, we have to do that. But in this case, 3, 4, 5, right? It's just, a very special, Pythagorean triplets. So therefore, if you're looking for cosine alpha, it will be adjacent by hypotenuse 3/5. Is that right if angle alpha is a second quadrant angle? So, I mean, okay, so why is it negative? Yes, the quadrant thing, right? A smart trig class, right? In the second quadrant, only the sine function and the reciprocal are positive, so cosine is negative, right? Yeah, that's exactly what we did before. So now, guess what? Letter B, the cosine beta is going to work out even better since it's a acute angle, right? So let's say since sine beta is 1/2, if you draw the right triangle, this is beta, opposites 1, hypotenuse 2, adjacent is radical 3, right? Therefore, cosine beta is radical 3 over 2, and it's positive since everything's positive in the first quadrant. And the reason why they wanted to figure it out cosine alpha, cosine beta, and with sine alpha, sine beta given in the first place. So now you can work out letters C and D, right? Because if you can expand cosine of some of the angle in terms of cosine alpha beta, sine alpha beta, right? The same thing for sine alpha plus beta, right? You have all the ingredients, right? Ready to go. You just have to put them together, right? So why don't you complete C and D? Right, go ahead. Don't freak out if you see some pretty ugly numbers or irrational numbers. They're meant to be like that. You do have some pretty good right, conclusion from those first 2 letters. But later, once you combine them in such a way, as you saw from those sum of difference formulas, I think it's, not as nice as before numerically. Yeah, definitely. And this is the reason I'm trying to show you the work for almost all the questions, because those are the work I'm expecting to see if you get FRQs like that, right? But you see that, I sometimes remember the results, but, if there's not a special angles, I would have got those answers on a calculator. But you do want to show me that you're able to, use sketches, right, or any kind of algebra to get to those results, but leave the last step of calculation to the calculator. I see some hands up just now. No? Oh, okay, yeah. In this case, well, it depends on how you want to do it. You're trying to find out the alpha and beta. So now, since didn't ask to find out the actual value for alpha and beta, that means you have the freedom to go with either degrees or radians, but you have to be consistent. So let's say if you, so I don't know if you're thinking about doing the inverse of that. So if you do that, if you say that I'm gonna keep the degree, then later on, if you take the angle alpha back into C and D, you have to be in degree as well, right? Yeah, as long as you're consistent. Since I'm not asking for the angle, then you have the freedom to do whatever you want. Sure.
A specific question, like since I already knew what each of them was, I just used those instead of like putting sine and cosine.
So it will be fine as long as you get the right answer. Now, if you don't, then I'll try to go back and see what you can get some points for. So let's say if you made a mistake over here, I'm assuming, I'm just saying, right? If there's a mistake over here, then you don't get a point for that step, right? So I'm assuming that you're going to also lose the point for the answer. So if I'm able to see that, oh, you actually got everything right, from the substitutions, you might get a point for that. But I don't see the formula, so what I'm going to give you a point for. So it's going to be like maybe 1 point for how you started, 1 point for some substitution, right? You know what I'm saying? Yeah.
Yeah.
So now, so if you don't mind, let me talk to the whole class about the same concern. Guys, so let's say if this is the test question. And, I start off with the right formula, right? And for some reason, I messed up this guy, right? So instead of putting radical 2/2, I put 1/2. So everything later is wrong, right? So if that happens, I'm going to go back and see what I'm going to give you points for. So you have the right formula, a point, right? You have the right, identification of those angles, a point, right? So you have the substitution of the angle correct, 3 points, right? Or you get some, some algebra wrong, a point off, and of course, the wrong answer, right? 2 points off. So you get 3, right? But that's based on you show me everything. So let's say if I go back and say, well, because you're so confident, you just show me that without anything else. I'm not going to assume you know these. So there's no points I can give you for. There's nothing I can give you points for, right? That's the right way to put it. So I'm not saying that you have to show me everything. I'm saying that I'm grading your work in FRQ by looking for things you're going to be awarded a point for. So you figure what you have to show me. And that's why I'm showing you all the work so you can see that what I'm expecting. Okay? But if you're that confident, get the right answer, show me that step. I know that you must have figured out everything, right? You get 5 points. Okay? But I mean, if you want to risk it, then some of the easy questions you can definitely do that. But I'll say that you're better off to show me the work just in case. All right.